In this video, I'm now going over our first lesson, which is going over rational expressions and simplifying them. So just keep in mind that a rational expression is just a quotient of two polynomials. So remember, a quotient, guys, is like if we had division, like a fraction bar. So really, they're just like regular fractions. It's just now the rational expressions, we have to make sure that they are simplified. So along with simplifying, we're going to also focus on this concept here, which is identifying, because now that we have a fraction, if you ever have a fraction, let's say any number here, like even 12 or negative 12 or even x, anytime that you divide any value by 0 or variable by 0, you will get an undefined. So that means the same thing in our rational expressions. We cannot have 0 in the denominator. So we're going to also keep in mind this caution, and we're going to identify the values that would make this rational expressions undefined by making sure that the original denominator is equal to 0 when we're solving to identify those values here. So for example, before I start simplifying, if you look at the first example, we're going to take a look at though and say, okay, well, if I have 6x to the fourth power, the original denominator, I have to say that 6x to the fourth power, we're going to set and solve equal to 0. Well, here, if I divide by 6, I still have x to the fourth equal to 0. Then this is kind of a new, but if I have the fourth power, then I take the fourth root. Well, here the fourth root is also x is still equal to 0. So x cannot equal 0. That is the one value that makes this expression undefined. Now, here make sure that, notice how we just have a monomial. We have the one term over the one term. So for example, I see 10 and 6. Well, I notice that they're both even, so they're both divisible by 2. So with simplifying, this will now be 5 over 3. Then now we have our variable. Well, here I have 8 x's in my numerator. We're taking out 4 x's. So if I have 8 x's, but I'm taking out 4 x's, that means we have 4 x's. So we have x to the fourth. So that is our rational expression simplified. So go ahead and pause the video and try this. You try on your own. And here we go. So first off, I've got my denominator, 8x squared is equal to 0. I'm going to divide by 8, solving for x, right, to see what our value is, still equal to 0. Now I take the square root. So notice how x cannot equal 0 for this expression as well. That's what would make it undefined. Then focus on the value. Well, 16 divided by 8. Well, 16 divided by 8 is just 2. Now the variable. I have 11 x's in my numerator. I have 2 x's in my denominator. So if I have 11, but I'm taking away 2, that means now I have 9. So notice how with division, we're now subtracting the exponents. 11 minus 2 is 9, and 8 minus 4 gave us 4. So now the second example here. Notice how we got a little bit more to it, but before we get started, I'm going to focus on here trying to get this into a factored form. So this is, keep in mind when we're simplifying, and if I have these factors in a quadratic, I need to make sure there's nothing I can do with my x plus 2. So I'm going to leave that in my numerator, but this trinomial here can be factored. So with factoring that, I now have, well, what two numbers multiply to get us 6 and add to get us 5? 3 and 2. So that means that our denominator here, x plus 3 times x plus 2, this is over here, so I'm going to rewrite it, because now that we've got it factored, cannot equal 0. So if we were, as if we were solving this equation, right, equal to 0, that means x cannot equal -3 and -2. So those are the two values would make this expression undefined. Now let's continue simplifying. Well, I notice that they both have x plus 2. So in this case, that's what we're trying to do. We're trying to cancel out. So that x plus 2 will cancel out here with x plus 2. Well, that means what am I left with? Well, technically, you're left with 1. So this answer here is 1 over then x plus 3. So notice how you're going to figure out what can I factor and then cancel out to simplify. So go ahead and pause the video and try this you try on your own. And here we go. So I notice up top, right, x minus 4, nothing we can do about that. But I do have a trinomial here that needs to be factored. So I'm going to bring down x minus 4 and now continue with my factoring. What two numbers multiply to get you -8 but add to get you -2? -4 and +2. So now notice, right, that this original denominator we would set equal to 0 because these original cannot equal 0. So we've got x minus 4 times x plus 2 equaling to 0. That means x cannot equal +4 and -2. Now let's continue with our simplifying. Well, notice, what do the numerator and denominator have in common? X minus 4. So those two values cancel out, but here we're not just left with nothing, right? We're still left with 1. So the final answer is 1 over x plus 2. So now looking at example 3. Now look at this numerator. Notice how it's not like just x plus 4, right? We do have to factor. We have a GCF. We do have a GCF here because we have two terms. Now I noticed too that they don't have a number in common, but they do both have at least one x. So I can factor out negative because of my negative here, so negative x. That means also keep in mind, because of taking out this negative, that we're changing the sign. Because a negative divided by a negative is a positive, and positive divided by a negative is now a -4. So we took out that x here, so we had 2 x's, now we're down to 1 x. We had 4x, but now we're down to just 4 because we took out that x here. Then over, now we do have a trinomial. So let's go through and factor. So here I've got what numbers multiply to get us -8 and add to get us -2. Well, -4 and +2. So let's go back to now identifying the original. Because remember, right, this setting equal to 0, because these values, what would make this undefined? So that means x minus 4 times x plus 2 cannot equal 0. That means x cannot equal +4 and -2. Now let's continue simplifying. Well, what do the numerator and denominator have in common? X minus 4. So both x minus 4's cancel out, and you're left with -x over x plus 2. So now go ahead and pause the video and try this you try on your own. And here we go. So here I notice in my numerator that this can be factored. There is a GCF. I can divide both by 4. They don't both have an x though, just the 4x does. So not 4x, just 4. So 4 divided by 4 is 1, so 1x. Then negative, so minus 8 divided by 4, which is 2. Now the denominator. So here we do have our trinomial, so going through the factoring, what two numbers multiply to get you 10 and add to get you -7? -5 and -2. Notice in the end that goal is, right, when we're simplifying, to cancel out. Before we do that, remember, right, the original cannot equal 0. So now that I've got this in factored form, x minus 5 times x minus 2, setting that equal to 0, that means x cannot equal 5 and 2. So now go back to the simplifying. What could you have crossed out or canceled out? X minus 2. So you are left with 4 over x minus 5 is the simplified form. Now looking at example 4, notice how we have a trinomial in both the numerator and denominator. So that means we need to factor both of them. So I'm going to go ahead and factor the numerator. So what numbers multiply to get you -2 but add to get you 1? +2 and -1. Now let's go ahead and let's do the denominator. So what numbers multiply to get you -3 but add to get you 2? positive 3, and negative 1. But remember, right, our denominator is what cannot equal 0. So x plus 3 times x minus 1, if we were to solve that, right, equal to 0, that means x is equal to, or in this case, not equal to, negative 3 and positive 1. That's the values that would make this undefined. Now let's go back and continue simplifying. Well, what do the numerator and denominator have in common that can cancel out? X minus 1. So here we're left with x plus 2 over x plus 3. So notice how if you have the two trinomials, right? Focus on the factoring. X was equal, or a was equal to 1. So once you have that factored and you can figure out, right, what are the values that make the denominator of this expression undefined, then look to see what factors can be canceled out. So then pause the video and try this you try on your own. And here we go. So here, let's focus on the numerator. You had a trinomial. A was equal to 1. So what two numbers multiply to get you negative 24, but add to get you negative 5? Negative 8 and positive 3. Then here, now let's focus on the denominator, right? Remember, our denominator in the end cannot equal 0. So here, what two numbers multiply to get you 15, but add to get you 8? X plus 3 and x plus 5. So that means, right, that this cannot equal 0. So let's go through and identify. So if I had x plus 3 times x plus 5, right, equal to 0 when solving, then we would say x is equal to, or in this case, not equal to, negative 3 and negative 5. So now let's continue our simplifying. What could be canceled out? X plus 3. So x plus 3 and x plus 3. So the final simplified version or form is x minus 8 over x plus 5. So now with our last example here, notice in the numerator, we have a trinomial. So let's go through and let's factor it. But a is not equal to 1. A is equal to 4. Do we have a GCF? No. So what did that mean? Bottoms up. So we multiply a times c, or first to our last. So this is x squared plus 7x, but now minus 8. Now factor. What numbers multiply to get you negative 8, but add to get you positive 7? Positive 8 and negative 1. Excuse me. So now here, though, we're not done, right? Because we did bottoms up. Whatever you multiply by, now make sure to divide. So now divide by 4. 8 divided by 4 is 2. So in our numerator, we have x plus 2, and then bottoms up, 4x minus 1. Now in our denominator, which remember, right, cannot equal 0, we have a difference of two perfect squares because there's just the two terms. So this is a case of not needing I, right? Because this is a difference. So here, that shortcut is just taking that square root. Well, if that's just x squared, then that's just x here. And x plus, well, what is the square root of 4? 2. So x plus 2 times x minus 2. Now remember, right, that cannot equal 0. So I've got x plus 2 and x minus 2, if we were to solve, right, setting that equal to 0, that means x cannot equal negative 2 and positive 2, or those two values are what make this expression undefined. Now let's go back and continue our simplifying. Well, what can be factored out or canceled out? X plus 2. So you are just left with 4x minus 1 over x minus 2. So go ahead and pause the video here and try this you try on your own. And here we go. So here's our numerator, but a is equal to 3, not 1, and we do not have a GCF. So bottoms up. So I've got x squared plus 2x, but now minus 15. So what two numbers multiply to get you negative 15 and add to get you 2? Positive 5 and negative 3. But because we did bottoms up, right, whatever you multiply by, which in this case was 3, that was our A, divide by 3. So that means in our numerator, we have, well, bottoms up, So 3x plus 5, and 3 divided by 3 is 1. So x minus 1. Now let's go to the denominator, which remember, right, cannot equal 0. So here, factor, and a is equal to 1. So what two numbers multiply to get you -3 and add to get you 2? X plus 3 times x minus 1. But remember, right, that cannot equal 0. So I'm going to go through and identify what are those two values. So x plus 3 times x minus 1. If we were solving, right, equal to 0, then x is equal to, or in this case, not equal to, -3 and +1. So those are the two values that make this expression undefined. Now let's go back and simplify. What can be canceled out? X minus 1. So you are left with 3x plus 5 over x plus 3. Now, the last question was the extension question. So if you wanted to try it, go for it. Otherwise, there were no other problems to practice, but I'm going to also go through the extension. So pause it, try it, and let's see what you get. And here we go. So I notice up top in the numerator, it's just two terms, and it's a difference of two perfect squares because I can take the square root. So here with the numerator, you've got x, then plus 6, because square root of 36 is 6, and x minus 6. Then the denominator. Well, with the denominator, you actually have a GCF. I can factor out an x term here. So this is actually x times x squared, because you had 3 x's, but you take out 1, so now you're down to 2. That means here with 5, you had 2 x's, but we take out 1, so now you're down to 1x, then minus 6. So now with this expression here in the denominator, now we can continue factoring, but don't forget about the x. So x times. Well, what two numbers multiply to get you -6 and add to get you +5? +6 and -1. But now remember, right, we have to make sure and identify what are the values that would make this denominator undefined. So not equal to 0, right? Because that denominator cannot equal 0. But you have x and x plus 6 times x minus 1, all, if you were to think about it, right, if I were to set it equal to 0, or in this case not equal, that means x here cannot equal 0. This is x plus 6 cannot equal 0. And here, x minus 1 cannot equal 0. So notice how there's actually 3 values for this one, because x cannot equal 0 is one of them. Then -6 and +1. So those are the 3 values that you should have gotten that make this denominator undefined. Now let's go back and continue simplifying. So what value or what expression can be canceled out? X plus 6. So that means your simplified version, simplified form of this rational expression is x minus 6 over x times x minus 1.